GTL Debug Back-End from the Debug development tools. As contents, blah 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 blah, and then the history, GTL Debug Back-End history, and then the introduction. The introduction, the generic transjector library GTL is used to interact with the RTL simulators or emulators. This document describes how to load the GTL plugin library and how to adapt it to for special use cases. Related document, tutorial to start, and for more information about the software-only debug environment, please refer to its software-only debugging host MCI. So the tutorial to start is application assist 2 and setting up multi-core, multiprocessor debug environment, and the software-only debug environment. Tutorial to start is only available for the Windows. Contact support. Okay. Note: please help to speed up the processing of your support request by filling out the system information form completely and with the correct data. You minimize the number of additional questions and clarification request emails we need to resolve your problem. 2. Prefers 3. Click abbreviation definition. AMP, asymmetric multiprocessing backend. A backend contains a high-performance multi-core debug driver and the interface to the simulator or emulator. Duty. Device under test. A duty is part of the model that is being tested. GTL, generic transjector library, a plugin interface for the debugger's backend to access the transjectors. IPC, inter-process communication, a method to communicate between the multiple processes of an operating system, for example, semaphores, shared memory, or file pipes, or TCP. And TCP. RTL, the register transfer level. Models of this level describe a digital system by registers, signals, and processes, not using a complete list with timing information. Simulator. A simulator executes a model on RTL level, without using special acceleration hardware. SMP, symmetric multiprocessing. Transjector. A transjector is part of a system that interacts with the duty in order to analyze and control the duty by an external tool. System architecture. The total system consists of two process groups. The debugger processes containing the front-end and back-end, and the RTL simulation and emulation. The debugger's back-end hosts the MCI, contains a high-performance multi-core debug driver that is also used together with the real the hardware. The debugger's backend is extended by the third-party GTL plugin to access transjectors within the simulator or emulator. The GTL plugin and the RTL simulator and emulator communicate by proprietary protocol using inter-process communication of the operating system. The debugger's backend need to run with low latency to simulation and emulation due to the very high amount of the accesses to the transjectors. Therefore, the backend and the RTL simulator and emulator should run at the same machine. The debugger's front ends and power view can run a different machine, so the multiple power view instances can be connected to one backend in order to perform AMP debugging. Like this. Power view system configurations. The 32 PowerView instances can be set up in different ways. A single trait32 PowerView instance runs on the same host as the backend, say setup 1. This configuration can't handle AMP debug scenarios. 2. Multiple trait32 PowerView instances runs on the same host as the backend, say setup 2. 3. The trait32 PowerView instances run on a dedicated workstation, and the backend runs on another host, say setup 3. The Routerback Debug driver library hosts mci.so for Linux Mac users and hosts mci.dll for Windows users, can be integrated into the trait32 PowerView application or run as a separate process called the T32 MCI server. Running it as a separate process provides two main benefits. The MCI server can execute on the one host, whilst one or more instances of the trait32 PowerView execute on another host. 2. Multiple instances of trait32 PowerView can execute on a single host, sharing the MCI connection. Setup with a single trait32 PowerView instance running on the same host as the backend. Modify the config.t32 file as follows. ppi mci lib. Configure your system to use host mci.so. Setup 2. Setup with the multiple trait32 PowerView instances AMP running on the same host as the backend. Like this. Modify the config.t32 as follows. pbi mci server. Set up the usage of the host mci.so and open server port to 30,000. Open server at 30000 for the first instance. Instance auto. Consecutive number of instances or auto. Setup 3. Setup with multiple trait32 PowerView instances AMP running on another host. Workstation and like this through the TCP. Start T32 MCI server on the simulation host. MCI T32 MCI server port equal 30,000. Start T32 MCI server at port 30,000. Modify the config.t32 file as follows. pbi MCI server and node set up the connection to the M32 MCI server. Node 192.168.0.1 connect to the IP 192.168.0.1 port 30,000 at port 30000. Instance auto. Consecutive number of instances. Dedicated. Avoid to fall into setup 2. Case. Linux example. To start trait32 PowerView with a specific config file, use, for example, bin pc_linux and t32 marm -c config.t32. Configuring the GTL plugin. Note. The available transactor interfaces and their parameters are specific to the loaded plugin. Please contact the support of the plugin vendor to get more information about the total environment and necessary adaptations. A typical start sequence is shown below. This sequence can be written to the practice script file star.cmm, the ASCII format, and executed with the command do file. So, select GTL as the backend and certain port, sys.config debug port GTL0. Optional tell the system how to connect to the simulation server. System GTL server config server 1 colon 10,000 10000. Optional pass configuration option to the config to be the model. The sys GTL motor config option 1 0 option 2 1. Option tells the system to connect to a certain DUT. sys.gtl.modelName model_JTAG. Tell the system the use CG of transactors. sys.gtl.jtag probe name JTAG probe 0. Library name of the GTL plugin sys.gtl live name GTL plugin.so. Configuration usage of the model time-based configure usage of the model time-based instead of host-based to avoid timeout while the emulation is paused. sys.virtualtiming.time in target time on. sys.virtualtiming dot pause in target time on. Continue with the CPU configuration. Is CPU system CPU Cortex M3 select CPU system JTAG clock 1 MHz setup JTAG frequency. Sysop is connected to the emulation. Additional commands to configure ARM bus transactors. sys.gtl.arm DAP name configure system wide depth DAP transactor. sys.config.dap name configure the override the DAP transactor for core DAP instance 1 accesses. sys.config.dap2 name configure the override the second DAP transactor for core DAP instance 2 accesses. sys.config.debug bus name configure APB transactor to debug register of the core. sys.config.apb name configure APB transactor for APB memory class. sys.config.mem2 debug and bus name configure APB bus used for DAP2 memory class. sys.config.dap2apb name configure APB transactor for APB2 memory class. sys.config memory bus name configure AHB transactor that is used for E-class access when the CPU is running. sys.config AHB name configure AHB transactor used for AHB memory class. sys.config DAP2 memory bus name currently not in use. sys.config DAP2 AHB name configure AHB transactor that is used for AHB2 memory class. sys.config.axi name configure AXI transactor is for the AXI memory class. sys.config.dap2 AXI name configure second AXI transactor that is used for AXI2 memory class. In case the JTAG probe transactor is not used, it's recommended to configure an additional GPIO transactor to modify and sense the system reset signal. System sys.gtl.gpio name configure GPIO transactor to access extra signals as system reset when JTAG probe transactor is not used. GTL functions. A description of the GTL functions sys.gtl.connected connection status in general function reference page 339 general_func.pdf. Shared models. The DUT can contain multiple debug ports that are independent that provide different complete feature set as the listed signals or the control of a certain JTAG chain. The way to connect those symmetric multi-core systems is to start multiple Power View instances with the individual debug ports that share the same model of the loaded GTL plugin. The following picture illustrates a scenario. Power View, Core A, Power View, Core B. Debug driver, Core A, debug driver, Core B. This is the figure. And the computation of trajectory to Power View 1. Select GTL as backend and a certain port. sys.compute.debug port GTL0. Optional, tell the system to connect to a certain duty. sys.gtl.model name model_JTAG. Tell the system the usage of the transactors. sys.gtl.jtagprobe name jtagprobe0. sys.gtl.live name gtlplugin.so. Connect to transactors. sys.gtl.connect. Configuration of trajectory to Power View 2. Select GTL as a backend and a certain certain port. sys.config.debug port GTL1. Show the plugged model as for the debug port GTL. sys.gtl.show the model GTL0. sys.gtl.jtagprobe name jtagprobe1. Connect additional transactors. sys.gtl.connect. The influence of configuration commands. System options can be shared by the whole system, the debug port, or are individual for one Power View instance. The sharing levels is classified by the command path. sys.gtl. The affected current selected GTL debug port is shared by all Power View instances. sys.config. Affect only current Power View instance. sys.virtual timing affected the whole system. To keep the graphical user interface responsive to the slow RTL simulation, small operations such as reading state of the state or showing memory dumps take a long time. This chapter describes how to adjust the virtual time scale to the ultra slow simulator and how to reduce the screen flicker caused by the slow RTL simulation. To keep the user interface smooth, multiple tuning options can be set. The most of the important setting is the setup U-rate. Setup.U-rate. To configure the update rate of the trajectory to Windows, the processor's state is also polled by this rate. Setup.U-rate 10 seconds. Screen will be updated every 10 seconds. To avoid the screen update while the practice scripts are running, screen that off. Switch off the state of the Windows when a practice script is executed. Screen. Trigger a manual update of the Windows inside the practice script. In order to switch off the state polling when the CPU is stopped, the command sys.polling can be used, but the debugger can't detect when another CPU changes the state from stopped to running, for example, by software reset. The sys.polling df off disable processor state polling when stopped. This command map is once updated once can be used to read memory regions only one time after a break is detected. Map.update once 0x0 plus plus 0x1000. Read memory of the regions. This region is only one time after break. Okay. The analysis of the data display purposes it's recommended that you use the code from the trajectory to virtual memory (VM:) instead of the code from the target memory. Therefore, the code needs to be copied to the virtual memory when a star.elf file is being loaded. data.loader.elf star.elf minus slash VM. Download the code to the target and copy to the VM. The list.auto VM colon open source window but use VM colon memory. On-chip.access VM use VM memory for trace analysis. Timing adaptation. Trajectory to software includes a set of usual low-level driver routines to access the target. These routines have a certain timing that be adjusted to ultra-slow simulators that can be billions times slower than a real silicon. In general, there are code parts that pause the execution until wait until a timeout is reached or just a certain point of time. For example, when a simulation is 1 billion times slower than the real time, these commands can be used to adjust the timing in most cases. So, configure the uses of the mother time base instead of a host base to avoid a timeout while the emulation is paused. Sys. Virtual timing VT as time in target timing on. Sys. VT virtual timing pause in target time on. Make the pauses and the timeout as 100 times shorter. Sys. Virtual timing at time scale 0.01. This will limit any pause statement to a 10 microsecond target time. Sys. Virtual timing max pause is 10 microsecond. This will limit any small timeout to read register to 1 millisecond. System virtual timing to max timeout 1 millisecond. The following time in the system commands are available. Sys. Virtual timing max pause, limit pause, override timeout, setup pause time base, multiply pause with a factor, and set up the general time base is multi-time based with a factor, can disable hardware timeout, multiple hardware timeout, best for artificial time calculation, insert pause after each action to slow down timing. Now the troubleshooting the GTL backend. Symptom. Host MCI GTL ERR or cannot load library. Code. Different ELF classes are used for the host MCI, .so, DLL, and the GTL plugin. Remedy. Start compatible combinations of host MCI.so and the plugin and for example, both must be 32-bit or 64-bit. The ELF class of the host MCI is the same as the ELF class of the process it loads it. T32M blah 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 or T32 MCI server. Status line shows power down. The T32 can't connect to a simulator. Check the simulation is running when the T32 starts to connect. View the area window for any diagnostic messages. Errors. Emulator subcore communication timeout. Debug driver algorithm took longer than expected. The incorrect value of the sys. Virtual timing time scale or sys. Virtual timing hardware timeout scale. JTAG specific. After the signals and parameters are collected with the tab of the DUT, a PowerView JTAG diagnostic should run. Show the result and errors area.view. Set up JTAG clock simulation clock based. Base the sys JTAG clock 1 MHz. Analyze the JTAG chain for test purposes. Sys detect daisy chain. Symptom. When the IR and DR lengths are both 0. Probably TDI is connected to a TDO without a DUT JTAG tab between them. Remedy. Connect the TDI and TDO with the JTAG chain of the DUT. Symptom. TDO stage constantly high or low. TDO signal is not connected or the DUT tab does not work. For example, is high in a cell. Remedy. Connect the TDO correctly, check the signals around the JTAG chain, and the simulation and emulation, and find out why the TDOs don't toggle. JTAG chain lengths cannot be determined. JTAG frequency might be too high. Use sys.jtag clock to lower the JTAG frequency. Note: the maximum clock of the tab TAP can be determined by the command sys.detect JTAG clock. The final frequency can be used to also depends on the motor behind the tab. The detected frequency is just the upper limit. The optimal frequency depends to the state of the simulation and can change during one debug session. Command reference: sys.gtl configure GTL debug port. Using the sys.gtl command group, you can configure a GTL debug port, GTL generic transient library, so that the command group is active after the GTL has been selected as the debug port. It allows to define and configure the used transactor and the GTL third-party library. The settings are shared among the trajectory instances connected to a certain MCI server. Optional step: open the sys.config dialog showing the debug port tab sys.config state /debug port. Select the GTL backend, activate the system GTL command sys.config debug port GTL0. See also Introduction in GTL Debug Backend. So sys GTL ARM depth name. Compare the name of the depth level transactor. By using this, the name for the DAP level transactor can be used. This transactor is active in all connected 32 instances. This GTL connect to emulation or simulation. sys.gtl.connect/try uses the settings previously configured with the GTL assist.gtl command to load the GTL library and connect to the emulation or the simulation. Try forces the command to continue quietly when the connection could not be established. Example: selecting the GTL backend, activate the system GTL commands, and configure GTL and connect to the emulation or the simulation. Disconnect from the emulation or the simulation. Disconnect from the existing connection to the emulation or simulation and disables the periodic reconnection try. Transactor name: disconnect the name the transactor when it is not used anymore. Unused: disconnect from all transactors that are not used anymore. From all transactors, disconnect from all transactors that are not used anymore. The sys.gtl.dma name of the DMA transactor. Configure the name and the usage of DMA transactor to have backdoor access memory to emulation and simulation. The backdoor access can be used by the data load command with the parameter DMA load. The sys.gtl.the explore display plugin capabilities. Column is default, structure, connected, type, and used by command. No config, config. The dialog can show the available transactor interface instances of the plugin, provided the optional enumeration interface functions has been implemented by the plugin. Default. Display a predefined set of the column. Structure. Contains a tree with abstractions, layers of the GTL API. The top level enumerates all instances of the models or scenarios. The available transactor interface instances are displayed below the model. Connected. The displayed whether the fidelity has an active connection to a model or the transactor instance. Mainly, the command sys.gtl.connect and sys.gtl.disconnect are used to change the connection state. So the type is type of the mode. For example, model or certain transactor type. Used by command. Display a list of configuration commands that are active and point to the transactor instance. Config. The display the configuration storing a configuration string of the corresponding sys.gtl.transactor config command. sys.gtl.explore default. sys.gtl.gpio name of the GPIO transactor. Compare the name and the usage of the GPIO transactor. GPIO transactor can provide a set of signals to access the DUT. For example, the reset signal or the JTAG pins. A GPIO transactor can be used in case no JTAG proof transactor is available, or when it doesn't implement those signals. System. sys.gtl.jprove name of the JTAG transactor, JTAG proof transactor. Configures name and usage of the JTAG proof transactor. A JTAG proof transactor can interact with the whole JTAG chain of the DUT. The sys.gtl library name of the third-party plugin binary. A library. Configure the third-party GTL library that is used to access the emulation or emulation. This command should at the last configuration command. The sys.gtl model command. Execute command in plugin. Execute the plugin specific command. sys.gtl model command do something important. The sys.gtl model configure emulation options. Configure the options to connect to the emulation or simulation. The particular options are defined by the third-party plugin. sys.gtl modeling. Select the emulation. sys.gtl.model name. Select a certain emulation out of a set of emulation. sys.gtl Pre-bundle, configure core optimization, auto, on, off, default auto. The option controls whether the thread W2 should collect write accesses and perform them later on, or perform them immediately. Collecting write accesses increases the performance but may cause problems with the original error handling or introduce a new effect in plugin implementation. No parameters. Display current setting in the directory to message line. Auto. The setting depends on the plugin and a trajectory interface. On. Pre-bundling is active for trajectory interfaces. Off. Pre-bundling is not active for trajectory interfaces. This GTL reset. Reset GTL setting. Reset the connection to the trajectory plugin and the GTL configuration. This command should only be used from the directory command line. Sys.gtl.reset resistance. Exempt GTL settings from reset command. Control the effect of the two reset commands, reset and a system reset, have on the GTL settings. On. The two reset commands have no effect on the configuration and the connection to the trajectory plugin. Off. The configuration and the connection to the trajectory plugin can be reset by the two reset commands. Example: selecting the GTL and backend activated system GTL command system config debug port GTL0. Example: the GTL settings from the to reset command sys.gtl.reset resistance on. The sys.gtl server configuration, configure server options, configures options connect to the server knowing all emulations. The particular options are defined by the third-party plugin. GTL sys.gtl.share models connect to the debug port to the existing connection. Links to the GTL debug ports in order to share the connection to the DUT across the multiple debug ports. More information about the scenario can be found in the backend manual. GTL debug port. Shared model. This GTL SWD name. Communicate with the target via SWD. Configure the trajectory name that is used to perform raw SWD communication with the target. SWD is serial wire debug. Usually, the name is the same as configured by the sys.gtl.jtag prove name because the raw SWD communication is an extension of the JTAG trajectory interface and one signal trajectory instance is used. When the sys.gtl.jtag prove name and sys.gtl.swd name has been configured, then the command sys.config debug port type can switch between JTAG and SWD. Sys.gtl.trace name. Name of the trace. Trajectory. Sys.gtl.trace name configures name and usage of the trajectory, a trace trajectory, and a trace trajectory can record off-chip trace data. Example: select the name for a trace, select connect to a emulation or simulation. Select the trace method, initially trace, and show control window, and trace method analyzer. Sys.gtl.trajectory config. Pre-configure a certain trajectory. A setup the configuration string that is passed to the GTL plugin when the trajectory is connected. When the configuration string for a certain trajectory changes, the trajectory needs to be disconnected. It is recommended to pass the configuration before the trajectories are defined, and because this avoids unnecessary reconnections. Trajectory name of the trajectory that shall be configured. configuration of specific configuration string, path to GTL plugin. Example, sys.gtl transactor config swd.1 and the target cell equal the sys.config.name swd underscore dap1 sys.gtl connect. Okay, today I read this material about the trade theory to GTL, the GTL Debug Back-End from Lauterbach Development Tools. Thank you for your time. See you next time.